like we say all the time. If you haven't subscribed to the channel and you like watching videos like this, then please consider subscribing to the channel. And without much further ado, let's start. So we've solved 43 problems so far, and we are going to look at the next problem. This is problem number 44, and pentagonal numbers. It looks a little similar to the previous problem, which had triangular numbers or something like that, but let's create a new problem. We'll call this problem 44, and let's write down the problem. Okay, problem 44, and this is the problem. It's called pentagonal numbers. Okay, and we are going to do this. All right, let's take a look at the problem. Pentagonal numbers are generated by the formula this. So it's a formula similar to what we have seen previously. The 10 pentagonal numbers are this. Okay, I'm sure if you put 1, 2, 3, 4 and so on. Let me see. 1, 3 times 1 is 3, minus 1 is 2, by 2 is 1. Okay, yeah, these are the pentagonal numbers. It can be seen that P4 plus P7 is P8. All right. Okay. However, the difference 70 minus 22 is not pentagonal. Okay. Find the pair of pentagonal numbers this for which their sum and difference are pentagonal. Okay, so we have to find J and K for which the sum and difference are pentagonal. So we have two equations, two unknowns. So two unknowns are J and K. Two equations are the values of Pj and Pk, and yeah, and they are supposed to be pentagonal. In are they two equations? They will be some sort of equation. Okay, and this is minimized. So I'm guessing that there are more than one pentagonal numbers where this is correct, right? And so we have to find J and values of J and K for which the difference is minimum. Okay, so we can do a brute force, but that will be like quadratic in J and K, so that's not a good option. So let's see whether we can find a easier solution. Let's see whether we can find an easier solution. Okay, so let's think about this. So the equation for the pentagonal number is Pn equals n times 3n minus 1. So by 2 times a half. So that means that 2 times Pn equals 3n squared minus n. So that's the equation for 2 times n. Okay. So now we want to find two values, Pj and Pk. Pj plus Pk, okay, is pentagonal, and Pj minus Pk is also pentagonal, and obviously J has to be greater than K. So that's something that we have to remember. So one of the things we can do is if that is the case, we want to find pj minus pk. That's the value we want to find. So let's assume that we want to find j and wait. Let's change the problem such that we are looking at two numbers, m and m plus n, something like that. Okay, now where j is m plus n and k is m, that way j is always going to be greater than k, assuming that n is greater than 0 or n equals 1, 2, and it's within a set of natural numbers. Okay, n in the set of natural numbers. Okay, so now if we can do that, then we can find this. So the problem transforms into pj is m plus n plus pm, that's a pentagonal number, and pm plus n minus pm, that is also a pentagonal number. Okay, so let's write down the equations. So if we substitute, okay, and let's multiply it by 2, and this will be 2 times the pentagonal number. Okay, so pm plus n is this is what we are looking at. So 3m plus n square minus m plus n, right? Okay, so that's m plus n plus 3, so this equation 1, equation 2. Okay, so we are looking at equation 1. This is that 2 times pm plus n, and then we have to look at pm, which is 2 times pm, which is just equal to 3m square minus m. That's the value. Okay, and we have to write this entire thing as a pentagonal number. So 3m square plus 3n square plus 6mn this should be m plus n. So minus m minus n plus 3m square minus m. Okay, so that's the entirety of it. So that makes it equal to, that's 3 and 3, 6m square, plus if we take all the terms together, that's 6m square, that and that, that's 3n square. This is 6mn, there's only mn, and then that's minus 2m minus n, and that's what it is. So we have to convert this into a pentagonal number of some form. So if we just look at this, this is 6m square minus 2m, okay, and then wait, am I doing this correctly? Let's look at the subtraction part first. Okay, so let's look at number 2 first. So number 2 is going to be that. So this is going to be 3m plus n square minus m plus n minus, this is going to be m square minus, and another minus over here, so this becomes plus m. So that's the value. So over here m and m is going to cancel. We will be left with minus n over here. There is going to be a 3m square plus 3n square plus 6mn. That's going to be from here. Over here we only have minus n left, and so this is done, this is done, this is minus 3m square. So we don't have an m squared term anymore, we only have an n squared term. So 3n squared plus 6mn minus n. So that is equal to 2 times pm plus n minus pm. So that's that. Now the question is, can we convert this into a pentagonal number that looks like that? That looks like that. Alright, so we have 3n squared, we have minus n, so 3n squared minus n, okay, plus 6mn. So that if we can find a value, right, such that if we can find a value for m, so for all integers, so this is important, for all n greater than 1 greater than 0, right, this is going to be a pentagonal number. So or rather, pm plus n minus pm is going to be equal to a half of 3n squared minus n plus this is 3 times m times n, right? So for all values of n, this part is going to be a pentagonal number. What we want are values of m and n for which 3 times m times n is pentagonal. This is a much easier problem to solve. Okay. Let's see. There's also the other property where 3n squared minus n minus pn equals 0. 2pn equals 0. So n equals minus b plus minus b squared minus 4ac, 4 to the 12 to the 24, 24 pn by 2a by 6 minus b plus minus b squared plus 4ac quadratic formula by 2a. Okay, so is that a pentagonal number? Okay, so let's check. Let's check. So if we look at 1, 24 plus 1 is 25. Square root of that is 5, right? Then plus minus 1. So this cannot be a negative because this will always be greater by 6. So 6 by 6 is 1. Yeah, so this is correct. This relationship, it has to be positive, so it cannot be negative. So if we have any number, we can check whether it's pentagonal by if this is integer. If that is an integer, then it's pentagonal. So we can check if this is pentagonal for all values of m and n. This has to be pentagonal. Another way of writing this is 3 times n times 3 n minus 1 minus 1 2. This is also always going to be pentagonal, correct? Wait. It's like that. So n times 3m can look like n times 3n minus 1 times a half. Okay, that comes here, that comes here, and so for all values of n, if 3m equals n minus 1 times a half, okay, or m equals 3 times n minus 1 times 1 by 6. Okay, for these types of values, this is also going to be pentagonal. Oh wait, I totally messed it up. I don't think this is correct. I spent 20 minutes doing something that is not correct. Yeah, this is totally wrong. This is totally wrong. Okay, let's just brute force this. How are we going to brute force this? We are going to just check whether a number is pentagonal with this formula, and then we are going to check for I in range 1 to 4,000. Okay, for G in range 1 to something like, let's go 1,000 first. 1,000 first. Okay, then okay, so let's find a function to check whether an given an integer, it will return a pentagonal number. So def pentagonal, it is going to be equal to, it'll take a integer number and it's going to return an integer. Okay, and return is just going to be this value here, which is n times 3 times n minus 1 by 2. Okay, so that's an integer. And is pentagonal? Is pentagon is pentagon. It will take n as an integer and it's going to return a bool, which says that it will return a true if the number is a pentagon, otherwise it's a pentagon number, otherwise it will return that it is not a pentagon number. Okay, so from math import square root. I have recently come to know that at Google they recommend you use you do the imports as close as possible to the place where it's used. I don't know why, but this seems to be something that's happening at Google, so just something to keep in mind. Okay, so is pentagon, we will compute this thing over here, np sqrt of 1 plus 24 times that n plus 1 by 6 by 6. So this val, some value is that 1 plus square root of 1 plus 24n by 6, yeah. And if val is, oh, I'll just return val equals int of val. Okay, then that's the pentagonal number. Let's check it. Okay, so pentagon, if I put a value of 2, is going to return 5. Is if I put a value of 5, is going to return true. If I put a value of 4, it's going to return false. So seems to be doing what we want. So now we want to look at, given p1, pi equals pentagon I. So that's the pi plus j, like that, equals pi plus j is pentagon I plus j. Okay, and I minus j, I plus j minus j is I minus j. So if not, this is not what we want. We want to find pj like that, which is the jth pentagonal number, and if I should go from I to, let's say we go to 5,000. Okay. Okay, so we go from, if I should probably go from I plus 1. Okay, if pi minus pj, if it is pentagon, if this is not not that, then continue. Okay, if those two, the sum of that is if it's not that, also continue. If the difference and the sum happens to be a pentagon number, then we will stop at a particular point and we will print I, j, and pi, and pj, and what else are we going to print? Okay, pi, this should be pj minus pi, pj minus pi, okay, and pj minus pi, because pj is always going to be one more, at least one more than that. And let us also import tqdm. So from tqdm.notebook import tqdm, and let's put a tqdm over here and a tqdm over here. I will put total. It doesn't have a length, and oh, this does have a length, so I don't have to worry about putting a total. Okay, maybe I'll stop. Okay, let's see whether we get a number. Oh, if I should come here, I should also break. Okay. I don't know why it did not. Okay, so this one was continuing. I did get values 1000, blah blah blah. There's a sum. This is the difference. This is the first triangle number, pi. The second triangle number, and the difference between the two is that 22 seconds. Okay, let's see. Okay, so I don't need a TQDM over here. This finishes way too fast. Okay, and solved is false. Break, and let's see whether it actually there we go. Okay, so this is correct. This is the right way to do things. About 2 seconds. Is it 2 seconds? Whatever. And it's 2 seconds probably because I was using this. Yeah. So okay. So so much for today. Let's stop over here, and we will continue next time. Again, if you like this content, then please consider subscribing. And other than that, see you next time. Bye bye.